Hello everybody, this is Math 145, Day 7, Part 2. We're going to Lesson 7, the inverses of trig functions. Of course, we had this in mind all along, talking about inverses. So here we go. It's like doing more examples for find the inverse. But in quotes, because it doesn't work using just algebra. And we'll see that in a second. Let's look at the cosine. Y is the cosine of x. And look at the graph. Either you can do that in your head or just make a quick sketch. Continues forever and ever. And it goes up and down. It's not increasing, not decreasing everywhere. Therefore, an inverse as such does not exist. On the natural domain, does not exist. To fix this, you pick an interval and make it as big as possible where the cosine is always increasing or decreasing, and the simplest one that comes to mind is from 0 to pi. So it's this part of the cosine graph. Pi is here, 0 is there. There, my cosine is always decreasing, and therefore an inverse exists. And what can we say about it? It gets a name. And my favorite name for the inverse is arctangent of x. And some people instead call it cosine with an exponent -1 of x. And I'll talk at the end for a second about why I like that first name better, arctangent of x. But you better be prepared to see that in books out there. People use either one. And generally, if they have a function f, the inverse is often denoted by f with an exponent of -1, f to the power -1 of x. And I don't like that either. I like to use a separate letter like g of x, like I've done in all examples so far. So I do not like that second one. I like the first one. So before we sketch a graph of this, remember mirror image? We can look at the domain and range of cosine and arctangent. We know the cosine, we picked the domain from 0 to pi only, and the range is between -1 and 1. And because the arccosine reverses that, we get the domain for the arccosine is -1 to 1, and the range is 0 to pi. So this is a general feature. You always switch domain and range to get domain and range of the inverse function. We still want to sketch that graph, but I'm going to just make a table with a couple of convenient values. Y is cosine x, and x is the arc cosine of y. So if x is 0, the cosine of x is 1, and that's the y. If x is pi over 6, the cosine is 1/2 square root 3. X is pi over 4, cosine is 1/2 square root 2. X is pi over 3, cosine is 1/2. And let's skip a couple nice angles. If x is pi, the cosine is -1. Okay, one more. In between pi over 2, the cosine is 0. Armed with these points in the plane, we can sketch a nice chunk of the graph of the cosine. And when we flip them, we sketch a nice chunk of the graph of the arc cosine. So now we can sketch. Let's see, this is something where you want to make a good choice of space, how long to make your axes. So domain from 0 to pi. So let's put that pi here. Midway in between, the cosine is 0. When x is 0, cosine is 1. When x is pi, cosine is -1. So something like this. That's your cosine. And with that blue, pick this chunk of the cosine. And then for the arc cosine, we flip those values around. So input is 1 in my table. Output is 0, and that's 0.1, 0. So that's about here. Input is 1/2, output is pi over 3. That's a little bigger than 1. So that's about there. Input is 0, output is pi over 2. That's about 1.5. And input is -1. That's about here. Output is pi. About 3. Okay. So I'm going to do that in red. Graph of the arc cosine connects those points like that. And it's supposed to be the red graph is supposed to be a mirror image of the blue graph. And I can't help it. This is something where I want to show you with the computer, so you see a decent example. Second. Here. So first, the graph of the entire cosine. There is no inverse. Then we just pick a piece of it in blue. And then we graph the arc cosine, which is the mirror image of that blue piece. And we get this kind of graph. And it's built in as a function called arc cosine. in my software, which is called Sage. If you ever want to Google that, sagemath.org. It's free. It works even without downloading. You get some kind of a window where you can type in these commands and plot everything. It can do every little last bit of your homework if you know where to look. But it takes some while to learn that. So I'm not saying you really have to learn this. But of course, if anybody wants to look at this, I'd be more than happy to give you a start and point you in the right direction. And that's what I use to make pictures for my exams and whatnot. So this is professional grade math. There's a lot of other websites which just plot functions for you, and that's plenty enough. So you can Google that. That should not be necessary to buy a calculator, but if you have one, figure out how to do it on your calculator as well. Back to handwriting. Come on. There we go. So the sketch, I mean, it's not pretty, but it covered the essential features. And now we could go through all 6 basic trig functions and do the same kind of thing. I'm just going to do the sine of the tangent. Sine graph, very roughly, like this. And the chunk to pick is from negative pi over 2 to positive pi over 2. Because there, the sine is an increasing function. And so, in brief, y is sine x leads to x is arc sine of y, and the domain that we're talking about, negative pi over 2 to positive pi over 2, the range is from negative 1 to 1, and it's switched to a domain from negative 1 to 1, and range from negative pi over 2 to positive pi over 2 for the arcsine. And if I just want to sketch that, it's going to go somewhat like this. Sorry, duh. I've got to edit that out in the video. I got my mirror image wrong because I didn't plot points to begin with. So I've got a point here, mirror image, and a point there, mirror image, and that's going to be like that. Yes, like that. Let's crowded picture. But it brings me to a larger point. Isn't there any easier way to do the whole thing? And the answer is no. And especially, this deserves skull and crossbones. Arc cosine is not the same as 1 over cosine x. Big difference. And you can think of a million reasons. It's a good exercise. Come up with some reasons yourself. Why is that not the same thing? Nobody said that it was. Why should it be? And if you claim that it is, you've got to come up with a reason why it should be. But it's not hard to actually come up with reasons why it's not. Totally different. And similar, the arc sine is not the same as 1 over sine x. Absolutely not. Common error. So don't even begin to think that way. The only way to think about it is y is cosine x, therefore x is arc cosine y. That's the defining equation. And so there is also no easier way to come up with values for arc cosine x, but to take an equation, y is cosine x, and solve that for x. There's no easy way to solve that for x. Your calculator has it built in and does some very clever approximations and comes up with 14 decimal digits. So that's good. And should also have arctangent, arctan, built in. Find the right button. And try it out with some of the values for our cosine that I gave you. So let's say we'll keep this clip short and do some examples with arctangent during lecture time. There's also worked examples in the book. And finally, we need to actually look at arcsecant and arccosecant and arcotangent, which turns out to be not that, nothing new happens there. If you have those 3 functions on your calculator, you can get by. And there's an argument you've made, as long as there's no basically new things happening, we don't need those other functions built in. Nothing essentially new happens with the other 3. Okay, so let's leave it at that for now and do examples for arctangent and the other 3 in lecture. We definitely need to discuss the arctangent, but there's a lot to swallow here. I want you to watch these, if you can, as soon as possible so we can talk about them in lecture. Bye for now.